right, so this problem explicitly says a car can accelerate opposite to the direction of motion. Well, isn't that just decelerating, apparently? Yes. Okay, so this car is decelerating on wet concrete versus dry concrete. It can decelerate, dry it can decelerate at 7, and wet it decelerates at 5. Okay, so somehow I got caught up in my bracelet. Okay, so figure out the distances necessary to stop a car moving. Okay, I can do that. So we need distances. So now there's no time listed. Oh, so I can use my super secret equation, which was something like v squared equals 2a x minus x naught plus v naught squared. I think. Yes, that's what it was. Okay. So it accelerates opposite to motion. Okay, so this is, let's do dry concrete. This is still being dumb. Okay, so I want my final velocity to be nothing, and it's equal to 2 times the deceleration of 7 times x minus, it starts at nowhere, starts at nothing, plus its initial is 30 meters per second squared. Oh, okay, I can do this. This is just math. Okay, so I have 30 squared, so I have 900 equals negative or positive 14x. So x is 14 over 900, 14 over 900. That seems like a really short amount of time. Wait, did I do it backwards? I did. 900 over 14. 14. There we go. 6, 4, 2, 8. That seems really big. Yeah, that does seem really big. 900 divided by 14? Oh, because that's gonna be a big number. Okay, about that. 64.3. Okay, that sounds a lot more realistic. So x equals 64.3 meters. Okay, doable? Okay, the same thing for dry. Okay, so that's written down so you can read about how to do that. Now it says do this again with taking into account the reaction time of 5 seconds. Okay, so now we have to deal with reaction time of 5 seconds. So essentially what that means is, first of all, he's going to go, so you have to think about this. So he's going to travel at 30 meters per second. Okay. And I've got my really bad pen going on here. So I know that x is equal to 1/2 at squared plus v naught t plus x naught. Okay, now this is just, I'm going to figure out how far he goes before he hits the brake, and then I can add those together. There's probably another way to do this, but I'm just going to do it this way. So my x that I'm looking for is that x. Now he hasn't hit the brakes, so his acceleration or deceleration is 0. His velocity is 30 miles or meters per second, and his time that he waited was 0.5 seconds. And he started at 0 location. Okay, so that means that he initially travels 15 meters before he hits the brake. And so I can either redo the other equation that I just did, or I believe, unless I'm just losing my mind, I will check, because, you know, there's always something, but I'm willing to bet it's just that plus, 15, x plus, So you just add the 64 thingy plus the 15, 64.3 plus 15, So, so 64 plus 3. Now, if you really wanted to do like a whole other equation because you felt sad that you hadn't done enough equations, you could... No, I'm not going to do that. That's just unnecessary. So let's just say our final x final is going to be his initial plus the whatever it was, the 64.3. 64.3. Come on. This is going to be really hard to do this. 0.3. So 79.3. And that's the total distance. And I should really label that with meters just to make sure everything is good. Yay. Okay, so that's a good start, I think. And I think 79 point whatever, is that what they got? Yeah. Okay, 79.3 dry. Okay. So that's kind of how you do that. Now looking at the rest of these, let's see. Suppose a car emerges, its initial velocity, and accelerates. How long does it take to travel up to that time? Okay, so again, just kind of using our base equation to get started. You just kind of got to know what you're getting into. So we have a car, we have a final velocity equals 1/2 at squared plus v naught t plus x naught. And let's see, he's got 200 meters to go, and his initial velocity is 10, and he accelerates at 2. And how long does it take for him to do that? Okay. Oh, I don't know why I called that v. That's supposed to be an x. Sorry, I wasn't paying attention. So final x. I would have gotten there when nothing fit. Okay, so he ends up traveling 200 meters, and that's 1/2, and is accelerating, so that's positive, and I already forgot the number, positive 2 times 2 t squared plus v naught. His initial velocity is 10, and again, unknown time, plus the initial position. We'll just set that to be 0. So basically I have t squared plus 10t minus 200 equals 0. And I can, put that either in a calculator. I don't think I can do that because it's like 10 and 20. Oh yeah, I can factor that. Look at me, I am factorable. 10 plus 20, 10 minus, or t minus 10, that's what I meant, right? Because that gives me negative 200 and plus 10 in the middle. Look at that. Okay, so the time is either negative 20 seconds or positive 10 seconds. I'm going to go with not negative 20 seconds. So it takes me 10 seconds to go up the ramp. Well, that's pretty cool. I did math. Is that the answer? Yay, except they actually worked it out. You don't have to do that. Okay, check your understanding. Oh, acceleration of a spaceship. A spaceship has left Earth's orbit and is on its way to the moon. Okay, little science person. All right. It accelerates 20 meters per second squared for 2 minutes. What are the initial and final velocities of the spaceship? Okay, we're just going to pretend that that's super sciencey. But, it's fine. So we have a total distance. I'm using this equation they've already conveniently written for me here, but they've written it in the wrong order. I don't like it in that order, so I'm going to rewrite it. X equals 1/2. Plus, every time I write it, it helps me understand it, and I get to know it better. We become better friends. So I recommend writing these equations out as much as you possibly can. So there's 1,000 kilometers equals 1/2, and he's accelerating, so this is positive t squared. Ooh, and t is 2. 2 minutes. Oh, 2 minutes. This is being a butthead. Okay, sorry, I said butthead. It's not 2 minutes. It's not just 2, because this is in meters per second squared, and this is minutes. Oh, I hate problems. And this is in meters, and this is in kilometers. Dang it. I should know better. So this is 1,000. Well, I wrote 1,000 kilometers, but it's really, how many meters? It's a whole bunch of meters. Because if I'm going to do 20 meters per second, I need like 1,000 kilometers is 1,000,000 meters. There we go. Okay, this is why units matter. Ugh. It almost got me though. Okay, I'm gonna be dead honest. This would have gotten me if I hadn't worked like literally 500 problems and been gotten on like 497 of them. Okay, just so you know, and I still get caught on these. 20 meters per second for 2 minutes. So 2 minutes is 120 seconds. Come on, girl. 120 seconds squared. It has some unknown initial velocity for 120 seconds, and its initial position I'm setting at 0. Okay, so now I just have to solve for something, and so I've got 100 million, or million, 1 million, 1 million, 1, 2, 3, 4, 5, 6, minus 20 divided by 2, well, 20, no, 20, come on, 20 divided by 2 times 120 squared, and that's 856,000. So 120 V naught equals 856,000. Okay, and then 856,000 divided by 120, that's supposed to be a division sign, is 7133 meters per second. 71, because I turned everything to meters and a second. So this is 7130, I'll just say 30 meters per second. So that's my initial. Let's make sure I got that right before we go too crazy. 7130 meters per second. Yay! Okay, that's there. And now we need to get the final. So we can use that other equation, is we know that the final velocity is going to be the acceleration times time plus the initial velocity. So the final velocity I don't know, but I know the acceleration is, I already forgot again, 20 meters per second squared times 120 seconds plus 7130. See, now my pen is being nice to me. I think it just like gets mad at me when I work too much. 120 plus 20, or times 20, plus, and notice how I'm going up and I'm grabbing the 7130. I'm not using the rounded off version. It's important. 9533. So final velocity, and I will go ahead and mark it with a C. Now you're, come on, girl. I can't tell you how many different drivers I've installed to try to fix this problem, but obviously they're not working. Velocity final equals 9533 meters per second. And I think that gets us to the end of this chapter, or this section of this chapter. You can hear my cuckoo clock again. Woo, what has happened? Okay, yeah. Oh, 2 body pursuit problems. Oh, there's more. Oh, okay, one more. Catching a gazelle. Oh, this is fun. And then are we done? Are we done after we catch the gazelle? Okay, we got to catch a gazelle, guys. Then we'll be done. Okay, come on, gazelle. Meow, meow, meow. That's what gazelles sound like in my head. A cheetah is waiting behind a bush. Why don't they have a picture of a cheetah so I know what they're talking about? A cheetah spots a gazelle running past the 10 meters per second. The instant the gazelle passes the cheetah accelerates from rest to catch the gazelle. How long does it take the cheetah to catch the gazelle? What is the displacement of the gazelle and the cheetah? Okay. So I've got cheetah. Whoa. Come back. All right. Come on, cheetah. Cheetah, cheetah, and cheetah. Okay. So cheetah's hanging out. So the cheetah speed, the velocity of the cheetah is given by the acceleration times time plus her initial velocity, which is 0. We could also say the position covered by the cheetah is 1, okay, 1/2 acceleration times time squared plus her initial velocity, which is 0 times t, plus 0, so that's the distance traveled by the cheetah. And now the gazelle apparently does not recognize that anything's happening, so just spends the same amount of time traveling. So the distance traveled by the gazelle will be 1/2 acceleration, but that's 0 t squared, plus 10t, her initial velocity, plus 0. And so the question is, how long does it take is when these two touch. So and then they meet, and then they give each other hugs and kisses, and they have a party. So basically, when is 2t equal to 10t? Oh, 2t squared equal to 10t. Well, obviously, one option is that t equals 0, because they're at the same place, I guess. So we're just going to let that go. So if we factor out a t, we've got 2t equals 10, so t equals 5. So it takes 5 seconds for the cheetah to catch the gazelle. And in that amount of time, the cheetah travels 1/2 times 4 times 25 divided by 2. 25 divided by 2 is 13.5, right? Yeah. Wait, hold on. Why did I say 25 divided by 2? I said 2t squared. The distance is 2t squared, not half t squared. So the distance is 2 times 25, which is 50. I can do that in my head. And then the total distance by the gazelle, I mean, it should come out to 50, but it's 10 times t, which is 50. Come on. So they each are going 50 meters, 50 meters. So it takes the cheetah 5 seconds to catch the gazelle, so they can play guess who. I guess that's what they do. All right, so, just kind of keeping things like that organized. Make sure that you kind of really want to make sure that you know what's going on here before you move forward. And again, I might explain it differently than how the book explains it, and that's why I record the videos, is just so that you have a different way of understanding it, and just to give you a different perspective.